So now I want to talk about our arrays and ordered arrays and unordered arrays. What an unordered array is kind of what we've been working with all along, where you just have an array of different elements in it. And so even with like the dragons that we made, we've dragon structs that we've made, that we have an array of them and they're in no particular order. So let's go look at one of those. So I just set up a array of dragons, and they're in no particular order with a level that's in no particular order. So if we're going to print this out, right, we have our function here that is, don't we have a function that prints? Yeah, there's a function that prints. And it only prints one. So if we wanted to print them all, we could make a copy of this. And it could be where we're passing in a whole array of dragons. So we don't have the and symbol. So so that's passing in an array. And we'd want to cycle through and print all of the dragons for int I equals 0 while I is less than, and we'll need how many we have. So we'll have int size, or count. And so our I is less than count, and I plus plus. And we're just going to print out all of our dragons. And you're going to notice we're going to have to change things up a bit because it's not happy, right? We need our I in here. And we probably want to also print out the I. So dragon we'll put I in there. So now it'll print it out each individually. So now we could use this same print dragon to print all of our dragons. So we'll just go in here and say print dragon, and then we pass in our dragons, and that there's 5 of them, right? And we could try compiling this, but we can see it's not happy, right? And it's not happy because it's still looking for the dragon and the and symbol, and it's because I updated one here, but I didn't update it in here. So I need to do the same thing here, right? I'm going to copy that dragon. I need a prototype for it. So it's just D with an array and an int count. And now when we go back to our main, it should be happy. So now we can compile and run it and verify that it worked. And so, so we could see that it prints out all of our things, but they're still in no particular order. So the thing about doing anything we really want to do with an array, we kind of need it in some kind of order. Because if I wanted, say I wanted to print out Meatlug and wanted to see if Meatlug was in there, I'd have to go and check every single one of the messages, right, to go see if I can find Meatlug to find out what level they're at, right? And the problem with that is in our little 5-element array here, it's no problem. It wouldn't take us very long at all, right? So we would just do like a while loop, right? While found, while not found. So we need a Boolean that's called found, right? So bool found equals false. And then we could say if dragons sub I dot name, or we'll need a count as well, right? So we'll need an int count equals 0, or we'll call it index because that's what we're looking at. Index equals 0, and we'll say index name, and check to see if that equals, right, we need 2 equal signs. If that equals Meatlug, then we're going to set found equal to true. And so then we'll have our index and say we could say here, right, cout meat lug was found at index. Right. And so if we run this, you'll see that we'll go through and not have anything. Oh, can you kind of see I'm in an infinite loop here? You know why I'm in an infinite loop? I forgot to update index. Oops. All right, we're going to update index plus plus, just adding a plus plus, and that'll automatically increment it. And so now, right now, it went in and found meat lug was found at index 3, right? And I didn't put a endel here, make it look nice or more readable. Endel. Now in our little, array where we only have 5 structs, this is no problem to have to go through each and every one of them. But if you're talking about 5,000 structs or 50,000 or more, you could see how this is really going to slow down the search, right? It's going to take a lot longer and longer and longer to find the value that we want and have it work, right? So what you need to do then is you need to actually put things in a sorted order, and then you could do more algorithms for shortening that search criteria. Because the point of saving data is to be able to access that data easily and quickly. And so that's what they're always like coming up with ways of shortening how long it takes to search data sets and find things. So what we're going to do now is put this in order and figure out how to sort it. So the next video is going to talk about bubble sort and what it means and how to sort this array into bubble sort.